22.7 using frequency tables. So, firstly, what is frequency table? So, as you already learned, doing a survey requires a lot of steps. And as for the last step, after you have gathered a lot of information, it is often convenient to put it together in a frequency tables. So from this table, you can then find the values of three other averages you have learned, which is the mode, the median, the mean, and also you can find the range. For example, a survey was done on the number of people in each car leaving the shopping center. The results are summarized in this table. For the number of people in a car, you need to calculate the mode, the median, and the mean. Firstly, the mode. The mode number of people in a car is usually really easy to spot. It is the number with the largest frequency. As for this case, it is true because the number of people in each car is true happening 198 times. So therefore, the modal number of people in a car is true. To find the median, you need to work out where the middle of the set of number is located. First, add up the frequency to get the total of number of car surveys, which come to 505. Add up all the frequencies. Next, calculate the middle position. To do that, you take 505 plus 1 and divide it by 2, which gets us 253. Now, you add the frequencies across the table to find which group contains the 253rd item. So, as you can see from the table, the 243 item is the end of the group with 2 people in a car. So 45 plus 198, that is 243. So therefore, the 253 item must be in the group with 3 people in a car. Therefore, the median number of people is 3. The mean. To calculate the mean number of people in a car, you multiply the number of people in the car by frequency. So that means 1 to 45, 2 multiplied by 198, 3 to 121, 4 to 36, and just give it up. So this is best done in the actual column, this column. To add this product to find the total number of people, add this thing together, which gets us 4,446, and divided by the total frequencies. That means 505. So you get that divided and you will get 2.9 rounded to one decimal place. Therefore, the mean number of people in a car is going to be 2.9.
In chapter 32.8, you study about groups data. So sometimes the information you are given is in groups data, in this group some way. So it's going to be called group data. There are 2 types of data, discrete and continuous. So discrete is data that consists of separate numbers. So for example, goals scored, suicides, marks in a text. So continuous data is gonna have any value within a range of values. So for example, height, mass, or time. And the mean can only be estimated as you do not have all the information. And you can imagine that discrete data is like, for example, like shoe sizes, you cannot have like 32.0567, but in continuous data, you can have it because they can have any value within any range of values. And in both cases, so when you're using the groups data to estimate the mean, you have to find the midpoint of the interval by adding the 2 end values and then dividing by 2. So now we'll go to an examples to understand more about the groups data. Now we'll go to the example. As you can see here is a table. There will be pocket money and the number of students have this pocket money. So now the question is calculate an estimate of the monthly pocket money. So to estimate it, assume that each person in each class has a midpoint amount. The build-up of the will be in this table. So to find the midpoint value here, you just have to add the two ends value together and then divide by 2. For example, in this line, 1 plus 0 and is equal to 1, and you divide it by 2, it equals to 0.50. And the estimated mean will be 120 here, and divided by 36 students, and it will be equals to $3.33, which is rounded to the nearest cent. So a small note that you cannot find the median or the range from a group table as you don't know the actual value. So you have to know the actual value to know the median or the range. So now we'll go to an exercise. So Jason brought 100 pebbles back from the beach and found their masses. So he recorded each mass to the nearest gram, and his results are summarized in this table, as you can see here. So what do you have to find? The first one is you have to find the model class of the pebbles. The second one is an estimate of the total mass of all the pebbles. And the last one is an estimate of the mean mass of the pebbles. Now, you can stop here if you want to do it by yourself. And yeah. Now we'll go to the answer. In the first answer, the model class of the pebbles, you have 100 smaller than m, smaller equals to 120 grams. As you can see here, in this class, you will have the most frequency, so it's going to be the model class. And an estimate of total mass of all pebbles is going to be 10,860 grams. And the last one is an estimate of the mean mass of the pebbles, and it's going to be 108.6 grams.
Last topic, 32.9, cumulative frequency diagrams. These seem news to you, but let me explain it to you so you can understand a little bit better. So, cumulative frequency analysis, it is analysis of frequency of occurrence of values of a phenomenon less than a reference value. So the phenomenon may be time or space dependent. So you can see here this example of cumulative frequency diagram. I think you guys have seen this a lot before, and you just don't know how they call it, but I think you would deal with this like a lot of times before. So it must be familiar. So how to calculate cumulative frequency? So you can calculate cumulative frequency by adding each frequency from a frequency distribution table to the sum of its predecessors. The last value will always be equal to the total for the observations, since all frequency will already have been added to the previous total. And this is the example of this the graph, and you will use the cumulative frequency table to draw this graph. And next up, the median. I think you guys used to it, so it must not be very hard for you. The median is the middle item of data once all the items have been put in order of size from lowest to the highest. So like this, an example, you have 1, 2, 3, 4, 5, 6, 7 items, and you place it in the order of size from lowest to highest. So you see here, lowest is 1 and the highest is 9, and the middle items is your median. So 1, 2, 3, 1, 2, 3. So the middle items, and so your median will be 6. And the same for this case. So if you have n items of data, you can find the median from the middle values is 1/2 nth value. And the median, again, but remember, if you want to find the median from a simple list of discrete data, you must use the formula 1/2 times n plus 1 value. The reason is that the cumulative frequency diagram treats the data as continuous, even for the data such as examination marks, which are decreased.
The interquartile range. By dividing the cumulative frequency into 4 parts, you can obtain quartiles and also the interquartile range. The lower quartile is the value 1/4 of the way up the cumulative frequency axis and is given by the 1/4 value. The upper quartile is the value 3/4 of the way up the cumulative frequency axis and is given by the 3/4 value. The interquartile range is the difference between the lower and the upper quartiles. Here is an example. The following data points represent the number of classes that each teacher at the high school teaches: 5, 7, 4, 4, 6, 2, and 8. And you have to find the interquartile range of the data set. Here is the answer. Step 1, put them in order: 2, 4, 4, 5, 6, and 7, and 8. Step 2, you have to cut the list into quarter, as you see in the picture below. Step 3, you can see that the lower quartile is 4 and the upper quartile is 7. You have the interquartile range is 7 minus 4 is 3.